Hi guys, I hope you're having a good day. These are the notes that we took last time we met together. I just want to go over these with you real quick. First we talked about standard form. We also talked about vertex form. Remember that in standard form, y equals ax squared plus bx plus c. Our line of symmetry in standard form is that x equals negative b over 2a. That's coming from this a and this b right here. The vertex is at negative b over 2a, comma, the value of the function at negative b over 2a. So we find whatever x is, whatever this variable is right here, and we substitute it into the equation to find out what our y value of our vertex is. We also know directly from the equation what our y-intercept is, 0, c. Whatever this number is right here, that's our y-intercept. In our vertex form, we know that we remember this, first of all, from transformations. We have y equals a times x minus h squared plus k. We know that k causes a vertical shift. It moves up and down exactly as you would think. So plus 2 would move it up 2, minus 3 would move it down 3. H causes a horizontal shift, but it moves the opposite of which way you think it should move. So x minus 3 would actually move to the right 3 because the value of h is a 3. Okay? The vertex is very easily seen because it's hk, and our line of symmetry is at x equals h. All that's stuff that we talked about last time. If you didn't happen to be able to see that, you can go watch the video on my blog about this particular lesson. Okay? So today I want to continue in section 3.2, talking about characteristics of quadratics. And we are on page 110 in your book. So if you would please turn to page 110 real quick, we're going to go over this core concept box. Okay? Turn in your books to page 110. Take your book out. Open your book to page 110.
Which page?
110. Okay? First of all, it talks about minimums and maximums. Okay? Now, it seems kind of logical about minimums and maximums, but I want to make sure you understand. Because the vertex is the highest or lowest point of a parabola, the y-coordinate of the vertex is the maximum value or minimum value, depending on which way the parabola is opening. So in this particular parabola, it's opening up, so it will have a minimum. It can't have a maximum because both directions, it continues on forever, so there can't ever be a maximum. In a parabola that's opening down, like this one is, it'll have a maximum, because it can't have a minimum because it goes all the way down in both directions. Okay? Again, like I told you last time, these core concept boxes in this particular section are really good. They have all the formulas, all of these things that you might need right at a moment's notice. You can just look at these core concept boxes. Okay? So if you have a parabola that's opening up, you know that this red line is the line of symmetry. Okay? The minimum value is going to be the value of the function at right along the line of symmetry right here. Now it's going to be the y value. Okay, so whatever the y value of the vertex is, that's going to be your minimum value. Okay, the domain is going to be all real numbers. Well, remembering about parabolas, it goes all the way to the left and all the way to the right. That's why your domain is all real numbers. The range is going to be everything greater than the y value of your vertex, because we say how far down does it go and how far up does it go. It goes all the way down to the vertex, so you're going to have the y value of the vertex since we're talking about range. It's going to decrease to the left of the vertex and increase to the right of the vertex. That's sometimes hard for you to think about because you think, I plot the vertex and they go up this way and up this way. So it seems like they'd be both increasing. But if we're reading from left to right, like we do as Americans, because we're not Hebrew, you know, we say what's happening as we go from left to right. Well, as we're going this way, it's coming down. Okay? I understand that there's an arrow that way. That's okay. It's supposed to be. But thinking about it going from left to right, as we're coming this way, the value of the function is decreasing. And it keeps decreasing until the vertex, which, like I said a minute ago, is the minimum value. And then after the vertex or the minimum value, it increases. Okay? Same way here on this parabola that's opening down. As we're reading from left to right, I mean, unless you are Hebrew, and then you just need to read English for right now, okay? So as we're moving from left to right, this value is increasing up until the maximum, and then it decreases, okay? You can look through the example here on this page. if you would like to figure out how to find a minimum maximum value. But please know that all you're really finding is the vertex. Okay? And on the next page, last but not least, graphing quadratics using the X-Intercepts. Remember when we did problems like this, when we had to find all the all the real roots? We found things like x minus 2 and x minus 5, and then when we graphed them, we looked at the calculator, and sure enough, they were crossing the x-axis at those values. Okay? So if you're given a formula or an equation, in this form, where it's some a value maybe or maybe not, and then x minus something and x minus something else, you know that if you set each one of these factors equal to 0, that is where it's going to cross the x-axis. Okay? Read through this paragraph if you'd like, but just keep that in mind. Looking at this example, x plus 3 and x minus 1, you know that this is going to cross the x-axis at negative 3 and at positive 1. Because if you set this equal to 0 and this equal to 0, you're going to have x equals negative 3 and x equals positive 1. And sure enough, when we look at the graph down here, it crosses at negative 3 and at positive 1. Okay? Excuse me. The negative 2, what's the negative 2 do in front of it? Well, what's the negative do? Negative reflects it over the x-axis. It causes it to open down. And what does the 2 do? Well, it stretches it out. So it's not as flat and curvy as this. It's a much sharper turn right here. Okay? Those are all the concepts that I wanted to talk to you about as far as characteristics of quadratics go. Please remember that on page 108 and page 109, there's some excellent examples. There's some excellent core concept things that we need to know, and also refer back to your notes that we took the last time we met together. If you have any questions, I will be here after school. You can come and see me after school. Otherwise, I hope you have a great day.